Hi, this is Steve Worona, and you're listening to Campus Public Safety Online from the National Center for Campus Public Safety. Before I introduce today's webinar, here's a brief orientation to the Adobe Connect interface we're using. Your browser right now is showing the title slide for today's talk. On the left side of your screen, you'll see a box labeled Questions and Comments where you can read and type messages. There's a tab labeled Everyone at the bottom of this box, and that's a tab you use for all of your general messages, including questions and comments for our speaker. We'll be breaking for discussion several times during the presentation, so please do not hold your questions to the end. You can also send direct messages to a specific person by hovering your cursor over a name in the attendee list. One of those names is Technical Help, and that's the place to go if you run into technical problems. We're also monitoring Twitter for your questions and comments. Use hashtag NCCPSwebinar. If you missed part of today's conversation, or if you want to see some or all of it again, this webinar is being recorded and captioned. The link will be available on the NCCPS webinars page in about a week. And watch your email for a link to a brief evaluation survey requesting your reactions and comments on today's session. Please take a minute to respond to that survey when the link arrives. We do appreciate your feedback. And now for today's presentation. Unmanned aircraft systems, also called UASs or drones, are a revolutionary technology that's making it easier than ever to collect information from above the Earth's surface. For colleges and universities, Uas Technology offers exciting new opportunities for carrying out research, inspecting campus infrastructure, and improving safety on campus. But these devices also pose a number of challenges, particularly on issues relating to federal regulations, privacy, and responsible use. To explore these challenges and opportunities, today we welcome Jarlath O'Neil-Dunne, Director of the University of Vermont's Spatial Analysis Laboratory. He's also founder of the university's UAS Team, which, since it began in 2012, has flown over 1,000 missions for activities ranging from disaster response to campus infrastructure assessment to agricultural research. He advises all levels of government, the private sector, and academic institutions on UAS technology. Jarlath earned a Bachelor of Science in Forestry from the University of New Hampshire, a Master's of Science in Water Resources from the University of Vermont, and certificates in hyperspectral image exploitation and joint GIS operations from the National Geospatial Intelligence College. For over a decade, he served as an officer in the United States Marine Corps with tours in East Africa, the Middle East, and East Asia. In 2008, he received the Vermont Spatial Data Partnership's Outstanding Achievement Award. Jarlath O'Neil-Dunne, welcome to Campus Public Safety Online.
Thanks for that introduction, Steve. It's great to be here. And what I hope to share with all of you today is one person's perspective on the use of UAS or drone technology. And I'll put some caveats on this presentation, which is to say, number one, please keep in mind that I'm not a lawyer, and especially when you get involved with drone operations, please make sure that you're consulting the FAA regulations, which are changing quite often, and also your legal team at your campus and other folks such as risk management. And you also want to make sure that you reach out to the experts that you may be associated with. So let's jump into things here. So to give you an overview of this presentation, I think this will really help as you have questions. First off, I'm going to start talking about drone technology. We're going to then move into some samples of applications, then get into drones on campus, look at implementation considerations and challenges, and then finally get into regulations. So if you have a lot of questions about regulations, please try and save those until we have our question break towards the end. But those other ones, go ahead and enter those at the appropriate section break. So let's get into why we got into UAS technology here at the University of Vermont. And quite a number of years ago now, we got slammed with what started off as Hurricane Irene and ended up being Tropical Storm Irene. And in some places in Vermont, dumped around a foot of rain overnight, which caused tremendous damage to our infrastructure. And what we realized early on in the damage assessment and recovery phase is that traditional technologies that we had used to capture data from above, such as manned aircraft or satellites, they didn't provide us with what we need, which is to say they didn't provide us with the locational information, the ability to make detailed measurements, the accuracy, the resolution, the currentness, and we couldn't get these products to people fast enough. So this was at a time when largely drone use had been limited to those in the military, but we had seen this emerging recreational space of drones, where drones were becoming smaller, more affordable, and easy to use. And so this was a unique opportunity for us 7 years ago now to get into using drone technology with initial focus on disaster response, and since we've broadened out in a number of areas. And this includes activities such as responding to a train crash. So our team marked the first case within the United States where UAS technology had ever been used to deal with a rail incident. Very, very valuable imagery that you could see there. And we were able to be co-located on site with the state police and provide them with the imagery and data immediately after we flew. We go out and do a lot of research and training activities. These could be visiting crop and field day with our team, getting out and interacting with middle school students, to in collaboration with Harvard, working on an international program for humanitarian organizations, instructing them on how to properly employ UAS or drone technology. A lot of our work early on focused working with transportation agencies throughout the region and how we could integrate UAS technology into their day-to-day operations so that they could make more effective and efficient management decisions. And then, of course, disaster response activities, where we participate in a number of exercises such as Vigilant Guard, which is a big FEMA exercise that happens on occasion, and then we've also done things like working with the Civil Air Patrol, looking at search and rescue for downed aircraft. And when we get
Jarlath, let me interrupt. We do have a couple of folks indicating that it's hard to hear you. So if there's a way for you to speak up or move that mic even closer to your mouth, that would be great.
Sure, I'll do that, Steve.
That sounds better. Thanks.
All right. And when we're working in these situations, what we find is that UAS technology can play an important role for a broad range of people, everywhere from the 12-year-old to the 62-year-old. And we've run workshops that include 4-H groups all the way to professional organizations. Now, when we're talking about drone technology, it's very easy to get wrapped up in the flying machine. But drones are a combination of the platform, that flying machine, and then the sensor that you mount on it. Now, most of us nowadays are using drones or are familiar with drones that have an imaging sensor. But you can imagine any type of sensor could be on here. Maybe it's one that detects cell phone signals, or maybe it picks up gases such as methane or CO2, or perhaps maybe even it detects radioactive materials. And when we have platforms, there are generally two types. One is a fixed wing type, so a small plane. This is made by a company called the EB here. It's a fancy flying piece of styrofoam with a lot of exciting electronics that is specifically designed for high precision mapping. And with these types of activities, for those of you that use GIS or Geographic Information Systems on a daily basis, you can produce all sorts of interesting products, not only orthorectified imagery, which is to say mapping grade imagery that we can integrate into geospatial software packages, but we can also produce things such as digital surface models and digital elevation models, or 3D representations of the Earth's surface. The other type of drone that we generally see are multi-rotor systems. This is an example of a quadcopter here. It's got four spinning blades. It's designed for inspection, filming, and video activities. So with this, we can go out and do something like create a 3D model of a railroad bridge, such as we see here. We can also then go ahead and fly over that bridge and take detailed asset management images that we can help people understand the condition of that infrastructure. And because this particular drone has the camera mounted on a gimbal, we can also fly underneath the bridge, point up, and take a photo there. And these drones sometimes are controlled autonomously, meaning that we will define a flight plan and just launch the drone and it will fly itself. Or at other times, we may have the operator interacting with it throughout the course of its flight. And the point being that no single drone will accomplish everything that you need it to. And in many cases, you'll want a fleet of drones not simply for their different capabilities, but because also drones do fail, parts fail, and you're probably going to crash one at some point in time. So with these drones, we can have not only traditional true color imaging cameras like what we have on our smartphones, but we can have things like thermal cameras. So those of you who are fans of the Predator movie, right, we know that the Predator was able to sense with thermal. That's what you see here. Important to keep in mind that as we shrink those sensors to make them small enough to fit on drones, we degrade the quality of them. So the thermal sensor that you're able to mount on a drone is not nearly going to be the same quality as a thermal sensor that you would get on a very large, say, flying platform like a helicopter or a plane. And drones generally are useful in those situations where the work is dangerous, dirty, or otherwise difficult to do. Some of the strength of drones are the speed of deployment. We can get a flying machine out there really, really quickly in any type of disaster response or emergency situation. They can offer real cost savings compared to traditional approaches of mapping from above, such as satellites or piloted aircraft. They can be often safer than putting someone out there on a piece of infrastructure, such as getting them underneath a bridge or getting them on top of a building. Of course, they can access places that are difficult for us to get to. We know the value of an aerial perspective is really unique for drone technology. And of course, we can produce data that we can then ingest into our other systems. I've shown you some examples of geospatial products and the fact that we can generate these 3D data sets, which give us these unique ability to model what we're seeing and sensing. There are some limitations, okay? Drones are a new technology, all right, which means they're inherently disruptive to any organization you implement them in. All of us have been part of organizations where we institute a new records management system or financial management system, and although in the long term that may be good, in the short term it causes disruption. As I mentioned before, drones do fail, and you're going to run into issues anytime you have a flying machine with moving parts. There are substantial privacy and perception issues around drones. They are very impacted by weather, such as high winds, sleet, snow, and rain. Batteries, which hamper our ability to use much of our technology when we're not plugged in, whether it be our cell phones or our laptops. Those same problems also exist with drones, only with much more serious consequences, meaning that the flying machine will fall out of the sky. They do require expertise, everything from understanding regulations to how to operate the drone to working the sensors to making use of the data. And you can collect massive amounts of data with a drone, okay? It's easy to go out there with a few flights and produce gigabytes, if not tens of gigabytes of data and derived products. Great, Steve. So I'm going to pause here and see if we have any questions.
Thanks, Jarlath. You are listening to Campus Public Safety Online, and today's presentation is from Jarlath O'Neil-Dunne. We're talking about unmanned aircraft systems on campus. If you have questions for Jarlath, type them into the blank line at the bottom of that questions and comments pod on the left side of your screen, and we will present them at several breaks that we have planned. Jarlath, Chip Youngblood asks about your favorite drone for photo or video images.
Sure. Well, I guess that depends a lot on your budget, right? And the first thing I'll say is anytime you want to buy a drone in your budget, buy drones in packs of 3. We joke around that there's the drone you had hoped to fly, but it doesn't work. There's the drone that you crashed, and then there's the drone that actually operates correctly. So there's a number of great, very affordable drones made from companies like DJI. Some of you have probably heard about the Mavic and the Phantom, which are really wonderful, affordable solutions. And then if you want to get into higher-end systems, especially for photo or video, you can look at more modular platforms like the DJI Inspire, which allow you to mount different types of cameras and sensors. But when you're getting starting off, a lot of these, what they call the prosumer platforms like the Phantom and the Mavic, tend to work really, really well.
What criteria, well, a question that came in, what criteria do you use to select the appropriate drone? I guess you've touched on that, but perhaps say a little more in general.
Yes, so you want to think about what your intended applications are with that drone and make sure you buy a drone that can carry out those tasks. You want to then decide how flexible your system needs to be. Are you interested in, for example, on a research and development side, mounting all sorts of different types of sensors on it? Do you need a modular platform, which is going to require greater expertise? Or are you happy with some of these so-called prosumer models that I mentioned before, that everything's integrated and it works effectively? And there's no perfect solution out there for these things, but it really does depend on your applications and your organization's expertise in making use of these things.
How many drones does one need?
Yeah, so I'll say that I think 2 or 3 is a good minimum, and I would say that they should be 2 or 3 generally of the same type or similar type, and the value in that is that you can swap out parts and batteries and chargers and all those types of things. In our case, for our team here, we have 14 drones. Those range from very affordable, low-end consumer drones that if we're running a workshop and someone crashes one, it's not the end of the world, to ones that run into the $30,000 that have integrated thermal video cameras, gimbals on them so we can fly under bridges and do some of those pictures that I showed you before, and also the fixed-wing systems that are useful for mapping activities but we wouldn't use for photo or video.
One of the drawbacks you mentioned was data deluge. Would you say a little more about that?
Sure. I think regardless of any imaging technology you incorporate into your organization, it's really easy to generate huge sums of data. Some of you in campus public safety may be making use of body cameras, right? And you're probably dealing with a lot of the issues around that. It's really easy to fly a drone, really easy to turn on that camera. What becomes harder to do is thinking about how you're going to archive, manage, distribute, and perhaps handle with Freedom of Information Act requests, if your organization falls into that category, with those various drone data products that you're generating.
I'm going to squeeze one more question in here, and we're getting a number of questions related to policy. And Jarlath, I know you said that you were going to get to policy later in the presentation, so we're going to hang on to all of those policy questions until later. Don't think we've lost them. But for now, someone wonders, what is the average weight for a fixed-wing UAV platform and payload that you prefer to use?
Sure. So one of the reasons why we like the fixed-wing platforms is they're inherently safer. So compared to the multi-rotor platforms where if they lose power, they're going to fall straight from the sky. With these styrofoam fixed-wing platforms, most are in the 2 to 5 pound range. And when they lose power, they will glide to the ground, and they'll probably hit you with about the kinetic energy of a soccer ball. So when you think about safety and risks, not all drones are created equal.
Thanks, Jarlath. We'll let you get back to your presentation, and I'll say again, there is still an issue about especially our relative volumes. I've done what I can to lower mine, so to the extent that you can, keep yours up.
All right, I'll continue to work on that. So let's dive into some of the applications, and I think this will give all of you a good perspective on what the various uses are of UAS technology across your campus. All right, and when you're thinking about UAS technology, right, it's not just going to be your campus public safety or police departments. It's going to be your students. It's going to be your researchers. It may be faculty that want to use them in classroom. This could be everyone from a forestry professor looking to conduct surveys of a woodlot to a historical preservation faculty member who wants to generate 3D models of buildings. So I'll give you a quick overview of some of our applications. We've used drone technology a lot to do traffic monitoring studies. They are great. We've done these for departments of transportation. We've done this on campus, on student move-in days to get a good idea of how traffic's moving. And that aerial perspective is really unique and gives you just a very simple view to let you know what's going on. Okay, we've also used them for crash scene reconstruction. We're seeing this within the public safety industry where we know on these major interstates the impact that shutting down a highway can have. And by getting out there and using drones, not just to create photos, but 3D models of the crash scene can potentially allow us to open up sooner rather than later. We've used them, as I've mentioned previously, in integrating with FEMA and our state emergency management agencies in disaster response exercises and actual disaster responses themselves. Doing things like this, which is here we did a drone flight in which we simulated. They actually laid logs across a road so to see how quickly we could identify the actual road in which was open to get to a community that was isolated after a storm. Drones have been very useful here in the Northeast where we get flooding every single spring. It's a part of life up here, and particularly in Vermont where our transportation networks and hydraulic networks are very, very tightly linked. So with drone technology, we can fly under clouds and we can get the images of the area at the resolution we need at the appropriate time. So here we're tracking flooding using color infrared imagery. This is just light that's a little bit beyond the portion of the electromagnetic spectrum, and we're looking at it in March, April, and then mid-April. So you can see where we go from ice-out conditions to flood conditions. So if we want to re-engineer our roads, we've got very, very good data at peak flood conditions to show where the flood happens. We can also use it to document the flood conditions themselves for a specific incident. That icy area you see in the middle there is actually a river. The area to the left is an agricultural field that's covered by icy water, and because of all the ice in the river there's an ice jam causing flooding over the road there, and you can see the Agency of Transportation truck that's blocking it. We know that road is impassable, but only with the drone data do we know the extent of the flooding in the event we want to redesign it in the future. We're able to build 3D models, not even using LiDAR data, but just being able to use hundreds of drone overlapping images. This is a 3D model of a road colored by the true color or RGB colors. This is an elevation model of that road, once again, simply generated from dozens of overlapping drone images. And then if we were to, say, suffer a catastrophic incident on that road, say a flood that washes out a portion of the road, we can then use these 3D data within geospatial software packages to make detailed measurements of that washed out area and accurately compute the volume that we need to replace that road. So if we want to get fill in there, rather than sending a surveyor out to survey it, or maybe it's an area that's inaccessible, drone technology and the 3D models coming from it allow us to do these advanced analytics. So don't think of drones as just photos and videos. Here's another example. This is downtown Barrie in Vermont. This is a storm that came through. There's a little brook in the center called Gunner's Brook, which was walled in decades ago when we thought it was a good idea and we could control streams. All that sediment damage that you see there is resulting from an overnight flood in which a few inches of rain fell in a short amount of time. With drone technology, not only do we have the images, but because these data are geospatial and we can bring them into our map products, we can then delineate the damage, overlay the property parcel boundaries, which are also digital map data, and then highlight those properties that have been damaged. Here in our community, we've also used it to do things like generate 3D models of contaminated soil piles. This is a ground photo of a contaminated soil pile. This is an overhead aerial view from the drone. The city needed to know how much contaminated soil they had. They didn't realize it was contaminated until they dug it up, and so they put it in a parking lot and covered it with some tarps. And so with a 7-minute drone flight and 30 minutes of computer processing time, we built these 3D models that were able to give them an accurate representation of how much soil they had to get out to a landfill that could handle contamination. And so you can imagine if you're doing construction on your campus and you need to do verification, perhaps a contractor has billed you for a certain amount of fill, an easy way to get out there and verify that is to use drone technology. You'll find that in your departments of natural resources, or your agricultural departments, that drone technology will be gaining interest. These are some images that we've done mapping an invasive species called water chestnut. We spend a lot of money here in the Northeast in trying to remove it. It clogs the waterways. And when you're thinking about your sensors on the drones, like I mentioned, not only just is it regular cameras, but we can also have other cameras. This is what's called a multispectral camera here, and the water chestnuts really jump out in that pink color. So we're looking at wavelengths of light that we as humans cannot see. And making use of this technology, of course, requires someone with an expertise in the remote sensing scientists. So if you're getting into this technology and you're interested in doing these things, such as making use of multispectral imagery, make sure you have the expertise within your organization, and chances are you have someone on campus. Asset management, as I've shown some examples before, is a really important use of drone technology. And you can get out there and just reach those places that are difficult. It may be a bridge, it may be the top of a building, it may be the side of a building. Wherever you want to go, a drone can get up there more quickly and safely than a person can. Here's an example of where we use drones after a storm in Vermont. It hit a town called Addison, which is on the shores of Lake Champlain. This storm was known as a microburst. It's a very violent downdraft, and it creates a pattern similar to a tornado. And our National Weather Service had interest to know, well, was this a tornado or was it a microburst? In order to do that, they need to survey a few hundred acres of where this incident occurred. And we had pre-event imagery, and that's available, Bing Maps, Google Maps, ArcGIS, whatever geospatial software platform you're using. But the value of the drone technology is we could go out the next day, map the area that was damaged, and for the National Weather Service, having the knowledge of where all those trees fell was absolutely crucial for them to make the determination that this was a microburst, and to do that efficiently and effectively over a relatively large area where doing a ground survey would have taken considerably more amount of time. We've used it also to document and analyze airport runways. So this is an airport runway that's pre-construction. This is it after construction. As you can see, the airport has been lengthened, and one of the concerns the FAA has when you've lengthened an airport, especially in the Northeast where we've got a lot of trees near our small state airports, is do you have the appropriate clearance for the approach path, that is the path the aircraft's going to come in when it lands, to the surrounding forested areas. Well, you can go out and measure all those trees manually, or you can get out, use your drone, build a 3D model, do those measurements, and then bring it into GIS, where each one of those tree icons there represents a tree extruded by its height from the drone data. And that block that you see there, that light blue colored block there, that's the approach path. So in 3D there, we can see that even though the runway was expanded, that the approach path still meets the appropriate FAA clearance, right? So it's not just having information, but verifiable information that can be visualized. In other activities, we've used drones to assess rock slopes. So you can see a team here. They actually have marked off the road so that when we operate the drone, we don't get close to any incoming traffic. And you can also see a GPS crew out there gathering detailed ground control information. And a lot of what you may want to get into on the mapping side can require that you assess the accuracy of your drone, and that may be involving, for example, people from your campus planning or survey departments to ensure that you're acquiring accurate data. Some other activities that we've done, this is an example of a gravel pit, and we've worked with the family that owns this pit, and they've been interested in knowing the volumetric estimate so they can sell off what they have in this particular pit. And once again, drone data isn't just about pictures and videos, it's about generating geospatial data that we can go in and then make detailed measurements, such as what we see here. The expertise needed to do that, of course, will vary within your organization. And we've also used it for construction analysis. This was a particularly tricky situation in that we had a construction site, but it was also an active area with many homes and people and traffic, and so we had to spend a lot of time getting participant agreements to operate drones in these areas. But here's a pre-construction image, and then here's a post-construction image. And what you see here, as they've redesigned the road and removed trees and done some construction, that we have verifiable information going forward so that we can check on the progress of this project. If there's any questions about environmental compliance or anything like that, we have a digital record that we can bring into our mapping software to check on those things. And this is some of the unique capabilities that drones give us, with the appropriate temporal resolution, acquiring the drone data at the right time, and the appropriate spatial resolution, meaning that we have the appropriate detail. And of course, here in Vermont, we've got a lot of these covered bridges. They're old, they're gorgeous, they're an important part of our state's identity, but they're also under threat from just age and then, of course, extreme weather events. And we can go out with our drones not only to survey that type of infrastructure, but then we can build these 3D models, such as what you see here. So if this bridge was going to be damaged, we could go out and rebuild it to its original specifications, and do that with a 30-minute flight and then a few hours of processing on the computer. Great. So, Steve, I'm going to pause here again and see what questions we have on the application side of drones.
Okay, and again, I'll say that we are getting lots of questions about policy, so they're chomping at the bit for that. But Solomon Singer asked a while ago, do you have any recommendations for the best platform for a college to build? Their applications are SAR, mapping, etc. And let me throw in the question about buy versus build. To what extent should campuses be thinking about constructing their own drones versus just purchasing them?
Yeah, I think it's a great question, and this really depends on what your focus is. If you need to get out there really, really quickly and do some flight operations, right, your focus is on getting images or data from that drone, you're probably better off buying something, right? It's just like most of us for our computers, right? If we want to start typing a document or do some analysis in Excel, we're not going to build a computer. There's a tremendous amount of value to building your own drone, not only from the learning opportunities, but if you want to do some very customized things, such as maybe integrating a methane sensor for research, you want to look at those models, okay? And you can do drones from scratch, or you can buy these drones that are somewhat modular that have these integration kits. And there's just, more options out there than someone can track. But if you want to go down the build route, don't do it because you're trying to save money, because you're going to need people who have expertise in mechanical engineering, sensors, perhaps even aeronautical engineering in order to get that up and running. And those costs, the human resource costs of having those people, can dwarf the cost of maybe buying 5, 10, or even 20 drones that are sort of low-end consumer or prosumer models.
Jane Ellis wonders if you have a suggestion for software to manage multiple drones on a campus.
Yes, so I think there's different types of ones. Keep in mind that under the regulations, you can only have a single operator per drone, so you're not allowed to have a single operator fly multiple drones. But when it comes to managing those drones, there's software packages out there, for example, like Drone Logbook, that allow you to ingest the metadata, the flight logs from multiple drones, so that you have that information stored. And if someone says, hey, where were you folks flying, you can go back and look at those records. So those solutions out there, I think, are very, very appealing to organizations, and they allow you to do other things, track battery life. Maybe you had a specific system failure. You want to know who was flying it. That metadata retention and logging of your flight operations, I think, is very important.
Luis Rodriguez wonders if there are any best practices to secure data that's being gathered during flight from being leaked to unintended parties while being gathered. And a related question from Ian Kendrick, at what point does footage, video, or still become a public record, or is that jurisdiction specific?
Yeah, so to the first question about storing the data. So some of the drones we fly, the data are stored on the SD card, so there is no real-time image feed to the operator. That can be very appealing for privacy concerns because you can say, hey, I've programmed the drone to do this flight path, just like we've done aerial mapping for decades in the United States. We have a history of doing this type of mapping. I'm not adjusting the drone based on that. And so in that case, really, unless someone recovers the drone in that SD card, they're not getting access. In other cases, the drone data are being transmitted back, and those may be, depending on the drone platform, in an unencrypted channel. It could be difficult to figure out that channel, but someone could potentially encrypt that. Then the other issue is after you've downloaded the data and stored it on your servers, are those servers secure, or is it on someone's laptop? And I think depending on the use, you've got to decide what are the appropriate security measures, right? And so, for example, if I'm doing a lab and I have a lab manual, right, that's something I don't really care that gets out in the wild when I'm teaching. However, if you're a public safety organization and you have sensitive data about an event, that's probably something that you want to treat differently, just like you would treat student grades or things like that. And I don't think you need to invent a new data policy just because you have a drone. Take a look at your existing data policies. If your organization is making use of license plate readers, body cameras, if you're in an educational institution where you have student grades and health data, you already have some really good policies and strategies for managing sensitive information. Make use of those before you go and reinvent the wheel.
Solomon Singer, who we heard from before, wonders, what is your favorite spatial data analysis software?
Yeah, I don't know if I have a favorite. We use a dozen. So for processing drone data, so taking it from the pictures and making some of these 3D maps, Pix4D, which we use, and Agisoft are two of the most common. And then once you do that, then you really opens it up to a whole host of software packages. You may want to use commercial packages such as ArcGIS, open source such as QGIS, or even 3D visualization softwares that are very specific for working with 3D models such as LiDAR and photogrammetric point clouds such as Quick Terrain Modeler. And as with your drones, where no one drone will do anything, or excuse me, everything, with geospatial software packages, it's unlikely that you'll find one that'll do absolutely everything you want it to do. The good news is I think these technologies are becoming easier to use and implement than ever before. And the fact that we can fly a drone, capture hundreds of images, feed them through a software package, and have a 3D model, an ortho-rectified image that we can then bring into our mapping software is really amazing.
One more during this break. Richard Bailey asks, is there technology that allows one to secure a specific area or airspace from drone operations?
There are some technologies out there right now, and we'll get into this regulations. No matter who you are, unless you're the FAA on this call, you have no jurisdiction over the airspace. So even Border Patrol has no authority to shoot down a drone that comes across from the Mexican or Canadian border into the U.S., right? So federal airspace is controlled by the FAA. You have no jurisdiction over that airspace, and that's important to keep in mind. Obviously, consult your legal team, but it's just like, we're near an airport here on the University of Vermont. Our university president cannot say, I don't want Delta Airlines flying over the UVM campus, right? That is not something he has control of, nor any more than New Hampshire can say, we don't want people taking photos of our state using satellites, right? This is controlled airspace. As soon as you put something in the air, you fall under the realm of the FAA, and it's important to consult with your legal team and pay attention to those FAA regulations.
Thanks, Jarlath. We'll hang on to the rest of these questions and present them during the last break. In the meantime, we'll let you get back to your presentation.
Great. So let's talk about UAS on campus. By far, the most important thing that you should be concerned with are your people. That can be either their perceptions of the people, but more likely if you're implementing the technology, their expertise, right? And once again, that's the expertise in the regulatory side of things. That may be the expertise in managing equipment and repairing equipment, flying those drones, analyzing the data, compiling video. All this type of stuff involves people. If you are strictly thinking, how much money does it take for us to buy a drone, you haven't thought about your drone program. For example, if you're thinking about starting up a campus police department, you wouldn't say, how much does it take for us to get a police car? Or if you wanted to have a fire department, you wouldn't say, hey, how much does it cost to get a fire truck, right? You'd look more holistically. You'd say, what are the people that we need? What type of training do they need to have? And then you'd begin to look at the equipment. And so on that equipment side, right, you've got the platforms and the sensors. Are those appropriate? Maybe you just need to shoot some video and still photos, right, in which something like these DJI Phantoms, these Mavic Pros, these prosumer models will serve you just fine. Maybe you're looking to do something more advanced, in which case you'll want to make sure that you have the expertise on your campus. You're looking to do crash scene reconstruction? Great, you have folks who understand 3D modeling. The information technology side, and I keep coming back to these examples of license plate readers and body cams, right? A body camera is not very advanced technology, right? We can all go to Best Buy and grab a GoPro and stick it on our forehead, right? And we have a form of a body camera. How we manage, archive, query, retain, and distribute those data are part of the real challenge. And your information technology costs from your drone operation will likely dwarf the costs of your platform and sensors in most cases. And then you've got to think about your policies and procedures within your organization, right? Who do you want flying the drones, right? Who grants approval for flights, okay? And balancing those policies and procedures with the fact that the FAA controls the airspace, right? And so once again, you cannot ban a drone from flying over your campus. If there's people out there in a lot of buildings, that person's probably violating some FAA regulations, right? But you cannot ban someone from flying a drone over your campus. You can certainly ban them taking a drone off from your campus, right? If you own the property there, that's a rule. But remember, the airspace is a little bit different. But within your organization, you want to think about the approval process and how difficult do you want to make it for people, keeping in mind that you may limit educational and research activities. So, foundations of a campus UAS program, 3 things come to my mind. Once again, coming back to those policies and procedures. And if you make them too onerous, you're going to set your college campus back compared to others, right? If people have to fill out 80 pages of forms every time they want to fly, there's no way your engineering programs or that agricultural researcher are ever going to get their drone programs off the ground. At the same time, you want to make sure those policies and procedures are protecting you and protecting the privacy. One of the things that came up on our campus when we were first talking about drones and privacy is someone said, well, we really need a regulation that stops people from flying a drone near a dorm window and taking a photo inside. And so my response to that is, don't we already have a policy that prevents someone from taking a photo inside someone's dorm room? And so let's not reinvent the wheel if we don't have to. I think leadership is really important, right? Who on campus is going to really take charge of the UAS program? And that person needs to balance the risks associated with operating drones with all of the benefits, okay? And if you're strictly looking at drones from all the bad things that can happen, your policies and procedures are going to be so onerous that you're going to really shoot yourself in the foot and hold your organization back. The most dangerous thing that we do on a day-to-day basis of our drone operations is driving to the site where we're going to fly our drones. By far the biggest risk we may face. And then finally, it's the support for your program, and that's the support on the regulatory and legal side, who can give you advice, right? Is there a consortium to form around maybe sharing best practices or drone data management software? And if you want to get into these back-end analytics, right, if your organization is looking to do that, who can you reach out to? And then finally, as it comes down to your information technology, right, do you just have the storage and server space to make use of all the data that you are going to collect? Your support, right? So support, and I just want to reemphasize these 3 areas again. Once again, legal and regulatory advice. Drones are extremely challenging because the regulatory landscape is changing almost on sort of like a bi-monthly basis, right? And you want to make sure that you stay on top of those and that you have someone you can reach out to get clarification. And we'll talk about this a little bit more within the university environment in a little bit because it's tricky and sometimes you fall under different sort of regulatory statutes. Your UAS platforms and sensors, right? Who are the expert or experts on campus around those, right? So maybe you're the campus police department and you want to get into drones. Who can you reach out to perhaps on your faculty and students who may already be flying drones so you can fly before you buy, so to speak, right? Test out some of these platforms so that you don't just buy something that some manufacturer is trying to sell you for $80,000 when it turns out a $1,200 system might work well. And I'll just keep hitting this home until people tell me to be quiet, but information technology, information technology, information technology. The back-end costs of the data management and all that goes into that can dwarf the other aspects of costs for your drone program. So I think there's been some really good examples out there, and I'll point to Oregon State University, where they have this Unmanned Systems initiative, and they've got this great initiative there where their job is not to make it difficult for people to fly drones, but to enable drone flights, right? So this moves away from this adversarial environment where saying, here's our policies, you can't do this, to they actually have an organization on campus that is dedicated to helping you succeed with UAS technology in your classroom or in your research project. And I think that's a great way to look at things and to really push your initiatives forward in a positive manner. But there's still some considerations you want to have, right? So what's your approval process? So do you just want to let anyone fly drones, and that may be what you decide to do, regardless if you're on or off campus? Or do you want people to file a plan first? And that plan may include some checklists of, hey, we want to see a licensed FAA Part 107 UAS operator there, to we want to see a screen capture of your flight plan, to maybe we even want to have a digital geospatial data set of your flight plan, right? And then data and metadata retention, right? So we've talked about this, especially as you get into public safety aspects, and if you're an organization that falls under Freedom of Information Act requests. How are you preserving your data, and how are you preserving your metadata, such as flight log information? And this can be very valuable because if someone says, hey, I saw a drone flying over here, and they call the university, are your people storing their metadata in a central place where it can be queried perhaps to say, hey, that wasn't our people to the best of our knowledge? And this is also very, very useful when you want to start tracking your equipment usage. And then finally, do you need a consideration around training, right? What level of expertise do you expect from people? Because you can go out and get a drone license, and that really, really tests your knowledge of the airspace and things like that. It doesn't test your ability to fly a drone. And all drones, all these different platforms out there, have different levels of expertise. Some you can program in the flight plan, chuck it up in the sky, and it'll do its mission and come back and land. Others that have something like akin to an Xbox controller can be very, very challenging to operate and probably require dozens, if not hundreds of hours of practice. So some considerations around implementation. One of the things that's interesting that we found is that people can feel very threatened by drones, right? So maybe you want to integrate it into public safety or to asset management. The people that are doing those jobs right now might be actively resistant to drone technology because they're worried it will take away their jobs. In all the cases which we use drones, we find that drones are really an augmenting technology, especially when it comes to public safety and disaster response activities, because those activities happen at all times of the day and under all conditions, and drones don't operate under all conditions. Your organizational structure, right? If you're a public safety organization and you want to get into 3D modeling of crash scenes, but you don't have any experts in 3D modeling and geospatial technology, you're probably not well positioned for that, even if you have a licensed UAS pilot who's an expert in flying them. You lack on the back end IT and data analytics side. Personal feelings, and this is especially true as you go up, right? If someone in your organization is adverse to drones based on what they've seen on television or some CNN reports or something, what have you, that can sink the whole operation. The regulatory environment is constantly changing, as I've mentioned. That can be frustrating. It's something that you need to keep abreast of, and doing things like following the FAA on Twitter can be very, very very informative and a good way to keep up on that. Drones are going to be an investment for you, okay? They're going to be an investment, and that payback period for that investment may be weeks, it could be months, or it could even extend over a year before it's adding value into your organization, particularly if you're having to hire new people or pull people away from their other tasks. And the other thing you want to think about is how much do you want to do internally versus how much would you like to contract out to an outside vendor. If your goal is to getting to a public safety incident very, very quickly, you probably want to have your own internal capabilities. Maybe your goal is to get a video feed of a public event that is scheduled months in advance. That may be something you can contract out to an authorized and reputable vendor. So some regulatory considerations here as we sort of wrap things up. Once again, I'm going to stress that I am not a lawyer, and I'm certainly not your lawyer. Please consult with your risk management, legal department, general counsel, and the FAA regulations. So, use type. Generally for higher education, the use type can either fall under the recreational guidelines. That's more of a student use teaching environment type thing. So in that case, the operator does not have to be licensed. Okay, as soon as you start doing things for your public safety, your asset inspection, or if I as a faculty member have a research grant and I'm out flying an agricultural field to see if I can detect an invasive species, that falls under what the FAA would consider more the commercial guidelines, licensed pilots and things like that. Regardless of what type of operation you're doing, things like controlled airspace, night operations, all those regulations apply, but know that if you go for educational operations, you don't need to be a licensed pilot. You may want to have a policy within your organization that says you want all recreational uses as part of educational activities supervised by a licensed pilot, but that's not required. Airspace issues are really, really tricky. Here at UVM, we are in controlled airspace. Many of your campuses may be in controlled airspace. we do not own that airspace. We own the land. We do not own the airspace. So when we fly at UVM, we used to have to call the airport and get permission. Now they have a digital platform called LAANC, LANC for short, that allows us to go online and register that. If you're in more tightly controlled airspace, Boston and New York Class B airspace, you're probably looking at months, if not years, of paperwork and approval process to be able to fly in those areas at this common time. You can get waivers for some operations conducting beyond line of sight. So as regulations, you're required to keep your drone in sight. And currently at this time, you cannot fly a drone at night, although it looks like the regulations are changing. But you can apply for waivers on those. Those waivers are generally controlled to a specific geolocation. So you can't just have a general, I'm going to fly over people, or I'm going to fly over regulations. So that approval process can be quite long for getting some of these waivers out there. Important to keep in mind that there are regulations on registering your drones, and the FAA just released more guidance about now that your registration number, they want to see it on the outside. So make sure that you have your drones registered, right? And these are things, if you have campus policies, you may just want to have links to these things. And then finally, there are some overblown privacy concerns around drones, and there are some real privacy concerns around drones. The key thing to keep in mind is that we have satellites flying above the Earth's atmosphere that can shoot video of the Earth's surface. There's dozens of satellites on any given day that are passing over you. A drone flying over you is not always providing unique information that someone couldn't get from another means. But when it comes to looking inside buildings and things like that, we do have an expectation of privacy, and drones can, in those situations, enable privacy violations. So these are all things to keep in mind, and these are all regulations that you want to spend some considerable time reading up on before you embark on any drone flight process. And this is just an example of something called AirMap. If you go to the airmap.io website, it's really nice. Here we are, that little push pin in the middle there is the UVM campus, and here we can see all the controlled airspace issues around UVM, and I can click on that and find out more about these advisories there. So using things like AirMap, or the FAA has a great mobile app called Before You Fly, where it'll take the location of your phone and let you know the restrictions in your area. Those types of applications, whether on a website or on a mobile device, can help you operate safely and effectively. And then, Steve, we'll turn it back to any remaining questions that we may have. I imagine there are a lot on the regulation side, and I'll try to do my best with, once again, keeping in mind that I'm not a lawyer and I'm not your lawyer.
We do have quite a few questions, Jarlath. Thanks. There were a number of questions involving sample policies, and you mentioned that Oregon State might be a model. Could you say a little more about the Oregon State policy, and in particular, how generally applicable is it? That is, should there be different policies for state versus private campuses, small versus large colleges, or any other types of considerations that the Oregon State policy might or might not be a model for?
Yeah, I think what makes Oregon State rather unique is that they have an office that's generated or focused rather on enabling the use of UAS technology. They also have a very good policy. You can look at ours at the University of Vermont. You can go down to places like Virginia Tech have policies. How your organization approaches your policy, right, is going to be very, very dependent on your mission and your focus and who's in charge of it. But I just encourage people to take a look out there. When we started our policy, we were lucky that places like Oregon State and other universities had gone down this path, so we could just go out and read their policies and be like, hey, what do we like about this? What don't we like about this? And it's always going to be that balance between, on one hand, you feeling that you're promoting safety and responsible use of drones, but then the risk of going too far where you end up hampering your organizational mission, both from a public safety and from an educational perspective, by having too many restrictions.
Are there mailing lists or conferences or any types of groups where especially university folks are getting together to talk about these issues, or is it still too early in the technology?
I haven't seen that. I think what's great nowadays is everyone has their policy online, so it makes these things easy to find and easy to search out. And so, like I said, I think going out to those, and then you have colleagues at those institutions, or of course reaching out to perhaps the person who's the party behind the policy will be a good way to go.
Zachary Borst, your colleague, has been talking about the drone logbook that apparently you put together, and a number of people have some interest in that. So perhaps say a little about how that's used, how it originated, what the purposes are, and the extent to which folks can easily copy that.
Sure, yeah. So we have, we use a commercial piece of software package called Drone Logbook, and that allows us to store our batteries, store our drones, store our pilot license information in there, track our flights, upload the flight logs, do flight checklists, all those types of things. You may want to use a commercial product like that. I think Skyward is another one out there. You also may want to develop your own, and you may just say that, hey, you know what, you just have to have a record of what you did when you went out there, right? Or you may want to have a policy that says, before you start flying, we want to see your flight checklist to confirm that you have one. And regardless if it's a digital technology or a paper technology, I think all those types of things are there. But there are two important things that come to my mind. You know, one is your flight checklist, right? We don't care how experienced the pilot is. He or she will go through a checklist every time before that drone goes up in the air. And then the second thing is metadata retention. As soon as we get back, we are going to store and preserve our flight logs so that they're accessible. Maybe that's an internal file storage system with flight name and date, or maybe it's using a commercial product out there like Drone Logbook.
Does UVM allow, Kim Miller writes, does UVM allow indoor drone flights, and if so, under what circumstances?
Yeah, so under UVM policy, we always have to go to risk management for approval before we fly. So we have requested to do drone flights indoors, and drones are flying machines with propellers. They will cut you. You may need stitches if they interact with you. So I think it's up to your campus to decide when is that appropriate. You know, it's probably not a good idea to have a drone flying around your hockey rink during a game, right? You're flying over people. That is just dangerous. But maybe there's a need for students to train inside, you know, one of the conference rooms, right, to get drone experience, and I think that's probably a very wise and reasonably safe use of indoor drone operations.
Some interest in recreational use of drones. Does the University of Vermont approve any recreational usage of drones flying over campus? This is from Robert Littell, saying, we have been reluctant to approve any recreational use due to the density of our campus. And then Rick Getter says, can faculty leading a group of students be considered recreational? So general considerations about recreation.
Yeah, around recreation. Yeah, we do, our policy does cover recreational use. I am not sure, since I don't approve the drone flights. I request for approval for drone flights. I'm not sure if we've ever approved one, but I know that if you want to launch from the UVM campus, that you, under our policy, have to get approval from risk management. So risk management would evaluate that, and a university can do that. We are also in controlled airspace here, so our campus is a challenging environment to fly, so anyone who wants to fly here recreationally would have to jump through two hoops. The other thing comes back to faculty and students, right? And my last reading of the FAA's educational policy, and you'll want to make sure that you go out and read this, but it's along the lines of students can learn how to design, construct, and operate small unmanned aircraft as a component of a variety of science, technology, and aviation-related coursework, and this falls under the recreational use, okay? I believe if a faculty member wants to do something and demonstrate for the students, because the faculty member is being paid, they probably have to be a licensed operator, okay? So just make sure you have your legal department read that memorandum from the FAA. But the good news is a lot of the things around learning fall under the recreational use cases. So your students want to fly some drones, as long as they're operating, you know, outside of controlled airspace or have approval, all that is good. Please do keep in mind that as soon as that transitions from we're doing this as a classroom activity to we have funding from the National Science Foundation for a research project, then your operator needs to be Part 107, and you fall under all of those regulations.
Dawn Moen wonders, what type of insurance liability coverage do you have on the drones?
Yeah, this was really interesting. I found out from our risk management people that they reached out to our insurance company, and the insurance company said, you know, given all the crazy stuff that happens at UVM, everything from sports that have a risk like hockey to students driving vans for research trips, to people going in MRI machines for research, right? Folks do a lot of things on campus. We're just throwing drone coverage into that, right? You may find out that your university does not have drone coverage as part of their blanket policy, in which case I've heard some individual research groups having to spend, in some cases, a few $1,000s a year in order to get that coverage. And once again, that'll vary by university, but there are organizations out there offering drone insurance coverage.
Thanks very much, Jarlath, and thanks to all of our viewers and questioners from around the Internet. Check the NCCPS webinars page in the next week or so for a link to the captioned recording of today's presentation, as well as a link to our speaker's slides. The brief evaluation survey I mentioned earlier should already be in your mailbox. It will take you no more than 2 minutes to complete. Please do. We read and act on your comments. The next Campus Public Safety Online is Tuesday, March 19th from 2 to 3 p.m. Eastern Time. Our speaker will be Alan Clark, Executive Director of Preparedness and Security Initiatives at Arizona State University, to discuss reunification planning. The registration URL is on your screen and clickable, or surf on over to the National Center webpage at nccpsafety.org. That's nccpsafety.org. And if you're planning way far ahead, mark your calendars for April 16th. From 2 to 3 p.m. Eastern Time, we'll have a presentation on adaptive continuity planning. April 16th, 2 to 3 p.m. Eastern Time. This just in, breaking news. Follow the NCCPS webinars page for the link to the registration form when it's made available. Campus Public Safety Online is brought to you by the National Center for Campus Public Safety with support from the University of Vermont Continuing and Distance Education and the U.S. Department of Justice. Special thanks today to Andrea Young and Dan Cardella. This is Steve Borona. See you next time on Campus Public Safety Online.